Hi folks, today we're going to begin a unit or a lesson on graphical displays, so different graphs that fit different data sets. Today we're going to talk about three types of graphs: dot plots, histograms, and stem and leaf plots. So the dot plot we already know a lot about. That's going to be our starting point. All three of those types of graphs are suitable for numeric data, and we will talk about what to do with non-numeric data at a later date. This is made up data of the number of indoor pets in 25 students' homes, and we are going to create a dot plot of it. We need to include, and actually I want to show you that, as you're making these graphs, every graph deserves to have the basics: a title, labels, equal spacing, all those things that make a graph a quality graph. So as you look at this particular thing, our title might be number of pets. The smallest number we have is 0 pets, so I'm going to start my number line at 0 and go through 8 at least, because that's the highest number we have. And for a dot plot, you'll remember that you create a dot for each data value. So we have 1, 2, 3, 4, 5, 6 zeros. That means that we should 1, 2, 3, 4, 5, 6. I'm going to ask you to pause the video, go ahead and make the rest of this graph, and I will do that as well. Here's my graph. One thing with a dot plot, as you want to try and keep the spacing between the dots equal as well. That just makes it a clearer picture to read. Dot plots have a very useful place in statistics. They work best when there are only a few data items. You can imagine if we had hundreds of households, this would not be the way to display them. They work well when you want to be able to see individual data values. Okay, I can count and see that there were 6 zeros here. You want to be able to see the shape. That's an important reason for graphing any data set, is to look at a shape. This one happens to be skewed to the right. You want to see or compare a few groups. Okay, so we used comparison dot plots in our very first lesson when we compared ages of laid off workers to ages of retained workers. Dot plots are good for that as well. The next graph we're going to spend some time with is the histogram, and this is probably statistician's favorite graph. This shows how often something occurs. A histogram is really a bar graph that shows frequency. And I have some guidelines for creating a histogram here, and a totally bogus, again, data set that might be the ages of teachers here at the high school, although I know that that's not true. Alright, so what you want to do is decide how many bars. Our textbook and some textbooks call them bins that you want. You can group several ages, in this case, into one bin, but each bin has to have the same width. I want to point your attention down to the bottom. A rule of thumb says that histograms are the easiest to read if they have between 5 and 8 bars. When you get lower than 5 bars, you tend to lose the real shape of the data. When you get more than 8 bars, your graph looks too busy. So between 5 and 8. I'm going to have us look at, we're going to use 6 bars or 6 bins here. You set up a number line for the x-axis. Our smallest age is 23, our highest age is 56. To find the width of a bin, folks, I'm going to take max age minus min, and then I'm going to divide that by 6, because I want to have 6 bins. My result, I'm always going to round up to the next highest whole number. Round up to the next whole number. So as you look at our data set, we're 56 minus 23, which is 33. And 33 over 6, well, it would go 5 with some. We're going to round up to 6. So to set up our number line, put a little lightning bolt because we're not starting at 0. You start with the lowest number, 23. then our bin we're going to be 6 wide. So you have to think about this here. This is a little bit weird. 23 we're counting. So that's our first number. 23, 24, 25, 26, 27, 28 is the last number that will go in that first bin. The next one starts at 29. So you can see how that 6 plays in here. I'm going to add 6 to keep creating bars, and that would be 35, 41, 47, 53, and the 59 up here. That should give us 1, 2, 3, 4, 5, 6 bars, and certainly it does. On the y-axis, we're measuring frequency here. On this axis, the horizontal axis, I'm going to put my label down below. These are ages. And our title might be something like teacher ages. Let's see. Between 23 and going up through 29, not including 29 because that goes in the next bar. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in there. 29 up to 35, but not including 35. These are going to go in our next bar. 35 up to 41, right there is the break. 41 through 46 goes in the next bar. 47 to 52, and then the rest of our ages. So the highest frequency in there was 10 is as high as we have to go. I'm going to make my axis go by 2's on the y side. And our first bar included 10 teacher ages. Or a way to read this is, there are 10 teachers whose ages are between 23 and 29. I'm going to ask you to construct the rest of the histogram, so please pause the video and do that now. Here is my histogram. You can see that the shape of this data is showing a skewedness to the right here. We're skewing toward the high end. Histograms are nice. Here are some benefits or qualities of histogram. Histograms work well when there are a large number of values to plot because you're chunking together values. They work well if you don't need or want to see individual data but are more interested in just the general shape. A histogram is great for that. This is also a handy graph because any calculator and most computer software packages for statistics will build you beautiful histograms. To create a histogram on your TI calculator, you enter the data values into a list, and folks, that is stat and enter. Stat and enter. I have already typed the teacher ages into list 1 here. You must enter the plot settings that you want. Second and y equals get you into the menu for statistical plots. You want to set plot 1, so you're going to do plot 1 settings. Hitting enter on plot 1, and you will see your choices. You must make sure your graph is turned on. For a histogram, in the type row you want the 3rd graph. You turn it on. The type setting you're interested in is the 3rd one. That's the bar graph. Hit enter there. Notice that it sets up for you. The default is XList list 1, which is good. That's where my values are. And frequency 1 means that we're using each data item 1 time, which is exactly what we want. Then we want to set an appropriate viewing window. And so I'm going to ask you to hit the window key. And for the histogram that we've set up, our X-min was the smallest number, 23. Our X-max, it's not our largest number. Instead, it's the largest boundary up here, 59. Our X scale, this is where our 6 belongs because we're going up by 6 each time. The Y min that I've shown was 0, and the highest frequency that we had was 10. So I'm going to make this go to, say, 12. All right, I want to write down those things here before I look at the graph. X min was your smallest value. X max was your largest boundary or your highest boundary. The X scale was 6 for the graph that we were doing. That's our the width of one of our bars. Let's take a look at that graph. Here's the histogram, and it looks surprisingly like the histogram that we created. When you're here, you may trace your graph. It will tell you the number of items in each bar and the min and max for them. So this contains things that go from 23 to just below 29. It won't count 29 here because that goes in the next bar. But as you trace across here, you'll see that it gives you the number of items in each of the bins or bars. Very good. All right, most calculators, folks, work the same way that the TI does. A value that would fall on a dividing line goes into the bar that's on the right hand side. When you change, this is just a note, when you change the width of the bin or the bar on your histogram, you can totally change your impression of its shape. So you have to be careful. That 5 to 8 bars is a good rule of thumb. A relative frequency histogram, folks, shows the percent of data or proportion of data that falls into each bin. So instead of having frequency over here, we would have percent. Still teacher ages. We're going to use that same data set. And you can change any histogram into a relative frequency histogram by dividing the number of values in each category by the total number of data items that you had. We had 28 data items in our set. We would use the same markings along the x-axis. The y-axis will change, of course, because it's now going to be percentages instead of frequency. But we had 28 items, so we want to keep that in mind. We went to 23, 29, and I'll finish here, and I'll ask you to finish as well. Our largest category, if you'll recall, had 10 items in it. 10 divided by 28 is roughly 36%. So we've got to get to 36. How about if we go 5, 10, 15, 20, 25, 30, and 36 up in here. I'm going to ask you to go ahead and create this histogram. The first category has 36% of the data in it. And I found that by taking the number of data items dividing by 28. Will you do that for the other categories, please? Okay, here's my relative frequency histogram. I've divided the number in each category by the total and then graphed that percentage. Notice here, changing the frequency into a relative frequency doesn't change the shape of the distribution. See, it's got the same kind of look to it. What changes is the Y scale. So, does changing? No. ... Only the Y scale is changed. Again, this shows us the percentage of items in each bar. The last graph that we want to talk about today is the stem and leaf plot, which you already probably have some familiarity with. This is still going to be a graph, so it deserves to have a title. These are teacher ages. What you do for a stem and leaf plot is look at the highest place value that all of the data has in common, and the tens is the highest that these all have in common. That means that our stem digit will be the tens, and our tens go from 20 up through 50, right? Then each of the leaves in the stem diagram is the remaining digit. These will be the ones digits over here. You write them out in a row, Some people put commas. I do not. And you can see what I'm doing. I'm going to ask you to pause the video and continue on. Here is my stem and leaf plot. You should always include a key. Not everyone is familiar with this type of graph, so somewhere to the side you would put something that looks like this. 2 bar 3 equals 23 years old. Very good. That's our lesson for today. I'm going to ask you to get out there, do the U-try. We'll talk about this more in school tomorrow.